Hey guys, this is Vivek here, and today in this video I'm going to discuss upon this topic, the calculation of equivalent resistance. But you're not allowed to use any mathematical formula. Yes, that's true. We all know how to calculate equivalent resistance in a parallel circuit or in a series circuit using mathematics. We are not allowed to use any formula, and I'm going to show you how you will do that. But before that, I would like to tell you something. First thing, I'm really sorry for bringing this video really late. I was very much busy last month with my exams and all other things, so I was not getting time enough to make a video. And the second thing is that we have just crossed 200 subscribers, and I would just like to thank you all for supporting me and the channel, and I promise you to bring more such informative videos in the future related to electrical engineering. You just keep supporting like that. Okay, so let's just go ahead. So here you can see on the screen there are two resistors, 5 ohm and 10 ohm, you can see. Okay, and each of them are connected in parallel. And how we calculate generally, so it's just equals to how we do that. This is R equals to multiplication of the resistance, both resistance, upon sum of both. This is how we do. The result is not that important. So this is the general formula we use. Okay, but we are in this video we are not supposed to do any such mathematics. We are not supposed to use any formula. Okay, we will see it by some different methods. So let us see how we can do that. So how without formula? So to do that, step 1, the first step is you draw a baseline, a straight baseline. Okay, and draw two lines. Here we have 5 ohm and 10 ohm, so corresponding to both of the resistor we will draw a 5 centimeter and 10 centimeter line with our regular scale, and it doesn't matter whatever the distance is in between. We have to draw these two lines, each of these representing each of the resistors. Okay, so we have 5 ohm and 10 ohm. So from the top of this 5 centimeter line, draw another straight line up to the foot of this 10 centimeter. Okay, and from the top of this 10 centimeter line, draw another straight line up to the foot of this 5 centimeter. Okay, so each of this line will intersect at a point. Just draw a perpendicular from that to the baseline, and the length of this line, whatever be the length, that will be L. So L is equal to R, that is the equivalent resistance. This is how it works. Yeah, that's not really useful because you have a really simple formula, but how this works geometrically is really interesting. We will see how it works, and I am going to prove you how this geometry is actually working. Okay, so I have done all the important mathematics firsthand, and let me show you how it works. So we have the same two lines. Okay, both of these lines are here, the 5 ohm and 10 ohm, AB and CD. Okay, these two lines. So it can be of any length corresponding to any value of resistance. So AB and CD, and from D we have a straight line coming up to A, you can see, and from B we have a straight line coming up to C, and each of these intersect at this point F. From F we draw a perpendicular to E. So this is the whole system. So the equivalent resistance is EF. EF is the equivalent resistance, and I'm going to prove it how it is, okay, geometrically. So first of all, there are two triangles. Here we have two triangles, that is triangle BCA and EFC, right? BCA and EFC. We have these two triangles, and both of them are lying at same angle. Okay, so we can say that both are similar triangles. So from the theory of similar triangle, we know the ratio of altitude of both the triangles is equal to the ratio of base of both the triangles. So by that we can say that EF upon BA is equals to EC upon AC. See, EF upon BA, altitude of the triangles, is equal to EC upon AC. Okay, so take it as first equation. Now let us come to another triangle, that is DCA and EFA. So DCA and EFA, we have both the triangles and both of them are similar. So by the last formula you can say that EF upon DC, just look at the figure, EF upon DC is equals to AE upon AC, right? We can say that. That's what I have written over here. Okay, EF upon DC is equal to AE upon AC. Now AE upon AC, AE can be, we can say from the figure that AE, which is this one, okay, so AE is equals to AC minus CE, we can say that, right? So AC minus EC upon AC, right? See, AC minus EC upon AC, which is equals to 1 minus EC upon AC. Okay, correct? So EC upon AC, from equation 1 we can see the value of EC upon AC. What's that? That is EF upon BA, right? EF upon BA. So we can substitute everything and we can say finally that EF upon DC is equals to 1 minus EF upon BA. So we have substituted the value of EC upon AC from equation 1, and finally from both the equation we have a final equation. Okay, so finally I have rubbed everything up. So here we had got the final equation, that is EF upon DC is equal to 1 minus EF upon BA. Just now we have to do some calculation, that is we can say from here that if we bring this EF upon BA on the left hand side, so we will have EF in common, 1 upon DC is equal to 1 upon DC plus 1 upon BA is equal to 1, right? Is equal to 1. So finally from here we have EF equals, if you just do a quick calculation you will get that it is equals to DC multiplied by BA or AB, whatever you say, upon DC plus BA. DC plus BA. So we had AB and DC as our resistors. So you see the product of the two resistors, that is AB and DC, and the sum of them, the ratio between both is equals to EF, and that proves that EF is the equivalent resistance. So this is how it works. This is really interesting, although it's not useful enough, but it's really great to note how this geometry actually tells everything we had an idea about finding out equivalent resistance. This is called the graphical or geometrical method of finding out equivalent resistance. So thanks for watching. Please subscribe to my YouTube channel to stay connected for more such informative stuff in electrical engineering. And once again I would like to thank you all for supporting my channel. Just keep supporting like that. And if you have any question, if you want to know something and you are not clear, please comment below. I have added the link to my Quora account and my Facebook account in the description below, so you can just go there and you can ask me over these platforms. So thanks once again. This is Vivek Choubey signing off.